Hello and welcome back to another video. In the last one, I showed you how to do some of the things we were doing on Linux on Windows, and we've gotten basically back to where we were on my Linux machine on a Windows machine. So if you're on Linux or you're on Windows, you're set up, and if you're on a Macintosh, you already have a terminal, so it's pretty much all the same thing. And I've got Node to work. Apparently, all I had to do was close the terminal in order to get it working. So now I literally didn't change anything but close it and open it again, and now Node works. You can see console.log test, and there you can see that Node works. The interpreter works again. So CLS clears the screen. On Linux, it's clear. So if you ever have like a bunch of stuff and you just want to clear, if you're on certain ones, you can just press Control S. It depends on what kernel you have. This is like a kernel hook that allows you to clear the screen with Control S. Oh no, it's a Control T. Control T takes the time, and it's a really useful feature, but it was on my Mac, so it's a Unix kernel hook. You can press Control T and see the currently running process, but you can't do that on the Linux kernel, I don't believe. But Control S, I do believe, works the same, so it clears the screen. It doesn't work in command prompt, so if I hit enter a bunch of times and press Control S, it doesn't clear the screen. It actually inserts a control, Control L, clears the screen. But it actually inserted this "L" character, which is what gets inserted if you hold Control and type. Again, the command prompt is a little archaic. It doesn't support more modern things, or it's not the same as a Linux terminal. So don't treat it the same way. But you just type CLS, clear the screen, and then this one's clear. But I had discussed what exactly I was going to be doing in this series, and this will be the last in this playlist for the introduction to the terminal, the Linux terminal specifically. And I decided that we are probably going to intermix the two, that being Python and JavaScript. So what I started with was Python, and this was the textbook that was given to me whenever I started university. It's starting out with Python. It's the 3rd edition by Tony Gaddis. It's a Pearson text. But there are other ones if you just go and look for them. Python textbook. You can see that all of these are more likely than not adequate texts for being introductory, but I decided to go with just the documentation tutorial that you can find on python.org. So if you go to, I'll just backspace, or I'll go back. So this is what's loaded initially, and I said that if you wanted to download it, instead of using a package manager, you'd have to go through here and follow your operating system's installation procedures. But there's also this documents section. And if you go to docs, you can see there's suggestions for brand new people, but we're specifically using the tutorial section. And in here you'll find everything you'll need to become, I think, at least an intermediate Python programmer. Some of the things that are not covered in the textbook I got was dunder methods, and things that were a little beyond an introductory level, such as how do I They're called decorator methods. They're like functions that affect how functions work. And that depends on their context in which they're used. This also doesn't cover things like lambda functions, which are functions that don't have a name, but they do something. They just don't have a name. You can't call them. So it's like they're being called in place, kind of. But one thing before we get started, and I will start the next video as the introduction to Python. It'll be in its own playlist, and I'll link it in the bottom. But before we do that, I just wanted to show that Python isn't actually written in Python. Python's not programmed in the Python programming language. It's actually written in a different programming language called C. And it's a kind of, you can think of it like it uses C on the back end of it. And it provides this abstracted layer in front of it that makes it easier to write and read. So if we go and type Python, and remember this terminal, the Python terminal, interprets programs that would be written in the Python language. So we can just say print hello, and it'll do essentially what echo did, is just print whatever we gave it to the command line. But this is actually, so let's exit. So this is actually something that's called a format string, where you can specify variables can be printed in here. So variables are like things you've defined to have some kind of a value, and those are represented with variables. Kind of like, if you remember how algebra worked, f of x equals x squared. You can think of the left half as being your variable. It's the thing that changes depending on what this assignment is, or what the equation is on this side. In discrete mathematics, there's a notation of assignment. So we're saying that whatever x is equal to whatever x was squared. And to simplify that, we can just say this assignment, x is assigned the value of 2. And so this doesn't run if you try to run this. In the shell scripting language, Bash, you can't have spaces to do this assignment. So if we say x equals 2, this will work, and then we can echo, which remember is the same as print in this case. You can, and in order to reference a variable in the Bash language, you have to use a $sign in front of the name of the variable, and then we get our 2 back. So that works the same way in Python. There's just a little nuance. You can use a space. You can't do this, because this notation isn't how assignment works. It's just not how it works, even though this is how it's defined in discrete math, which is a branch of mathematics you might study later on in your time I don't think you'll ever study this in high school, but this is something I had to study in university. So we can do this. Oh, this doesn't work. Like this. So now x equals 2. You don't have to, in this interpreter, you don't have to write x equals, or echo, or print. You don't have to say print x. You can, but you can just type x, and the interpreter will just print out what it is. If you go to here, you can't just type $x and get oh wait. You can't just type $x. Well, let me reassign x real quick. X equals 9. If you type $x, it gets it, but it tries to interpret it as a command. So you have to have something use it. So you have to type echo to just get the 9. And this is like a very brief introduction to L values and R values and this idea of assignment and things are equal to things. And I'll show you that these things are not, they're independent of a language. These ideas are independent of the programming language. They're all supported in all programming languages because these are fundamental things. And that's why I wanted to call this a programming fundamentals course. We're not going to get into anything that is specific to languages in this playlist, such as function decorators or dunder methods that are specific to Python. Because those ideas I haven't seen anywhere else other than in Python. We're going to be going over everything from what I've just introduced up to object-oriented programming, functional programming, methodologies of creating things, and what it means to write a good functional program. But again, Python is written in C. It was not ever written in Python. Even C wasn't written in C. It had to be written in something else, all the way down to like ones and zeros, on and off. Everything had to be written in binary, and then in assembly, and then in those abstracted languages that were built on top of it, that were eventually bootstrapped in their own language, but they weren't initially written in the language. In fact, I can go in here and say, what is C written in? And you'll find that it was written in assembly and then bootstrapped in C. See, it's bootstrapped. So they defined the functionality of how C worked in assembly before, and then they rewrote those functions in the language that they just made. That's what bootstrapping is. Languages that are bootstrapped, I believe Rust and Go are bootstrapped, even though they were originally written in C and C++. Even Java was written in C and then bootstrapped into Java. So this idea of being a polyglot and knowing a bunch of programming languages is kind of just the way things work. So it looks like this one was bootstrapped into like a mixture of C and C++ or Python. So being a polyglot is kind of like the name of the game here. And really knowing one language very well, a lot of those constructs transfer. Like there's an idea of assignment in every language, but it doesn't necessarily look the same. One programming language I can think of is Jai. Jai is in development. It's not even something you are freely available to use. The compiler for this language, the specification is available, but this programming language does assignment how discrete math does assignment, whereas Python does assignment like with an equal. Most languages you'll see do assignment with an equal. Other than Bash, you saw that Bash does it like this. It's very space sensitive. And you'll find that a lot of languages, or not a lot, a few languages are very sensitive to white space characters. Python is one of those that is sensitive to white space. OpenGL, I think, is another one that is also sensitive to white space. Make is a language that is sensitive to white space. White space itself is a programming language. So this is a programming language that uses white space as its it's kind of like, you can kind of think of it like Morse code or even binary code, like an arrangement of certain white space characters means a certain thing, and that's how white space works. This is a good idea if you're trying to like embed a program inside of a program and it be something that is hard to understand. If you're looking for obfuscation in security, if you're trying to embed a program or a virus in another program, you could do it with white space and then have a white space interpreter installed somewhere on the system. But it's just neat to read about if you care to read about this programming language. And there are literally hundreds of programming languages. Just some of them are just domain specific, and you'll probably never use them in your entire career as a programmer, but they exist for some reason. You might even write your own programming language. In fact, that is part of a university courses. Some you'll have to build a compiler for an existing language, and in some you'll have to build a language. And if you want that language to be worth anything, it needs a compiler. So you'll probably have to take a compiler's course before you take a programming language course in university. But again, Python is written in C. Everything abstracts everything else. I was looking at what specific version of JavaScript Node supported because I didn't know exactly which one. So we'll be going over the Python tutorial, and I'm not going to strictly follow the text. We're just going to be working towards a project, like I mentioned. And I figured that project should be something interesting that we could work towards. So the two I came up with were for Python. I figured we should do something that required some complex ideas that could be easily expressed in Python, and I decided we would build a CCTV, or a closed circuit television. Usually this is used in security for like security cameras and stuff. And in order to do that, you'll need a few things. You'll need at least a webcam. You'll need at least one webcam. And you'll need a computer to attach that webcam to. I'm going to use this tiny Raspberry Pi. You can use your own computer that you're working on. If it's a laptop, it probably has a camera in it. But you'd have to figure out how that works. This gets into some of the nitty-gritty. I'm using a Logitech, just a regular old Logitech, the one that's been popular for like 9 years. You go, yeah, C920. Just one of these. But really, you can use any webcam. It just has to be able to connect to a computer through USB. That's the only requirement, I suppose. And then whatever computer you're using has to have the webcam software, its drivers already installed. So you need a working webcam and then a working computer. This is a Raspberry Pi Model 3B Plus, I think it is. It's like $35. This is like $100 or $80. You don't really need a super fancy webcam to do this. And if you don't have a webcam, you can just follow along and create the program yourself, and then if you do exactly what I'm doing, you can be relatively safe in assuming that it'll function regardless if you have a webcam or not. So that's what we're going to be building in Python, a closed circuit television system. And in Java script, we're going to be writing our own personal website. So we're going to do a personal website. And this will cover some ideas such as HTML and CSS. And then I'm debating whether or not we should use some more complicated software in this project, and I'm thinking we might just leave it at HTML and CSS. And JavaScript is just, so these three usually go together. Reason being, HTML and CSS aren't strictly programming languages, although in recent versions of HTML you are able to do some basic programmatic things such as arrays and stuff, and I think maybe even variables, and we'll go over some of those. CSS is for styling. So styling is like having how you have preferences and things. So you go here and you go to settings. I don't know if this will open via, okay, we just opened VS Code over here. So this is the settings.json file for the Windows terminal, and you can think of CSS as similar to this. So it sets the name to this, although it's not exactly the same as this. It looks similar, and in fact you may have seen it because I showed you these things before. This over here on this side is the styles, which is what CSS is. And you can see the display. This is how the objects on the page are formatted, how they arrange themselves. All the colors are set this way for the fonts. In fact, the fonts themselves are set in this way. Like right here, font family. And this is applying to the entirety of the page. These are settings for entirety of the page. If you see things that are crossed out, that means that somewhere something is overwriting them. So they're being disabled, and it's just crossing it out to show you it is declared, but something's declaring something over it, and so this is crossed out. Probably the next step down, this thing that says the same thing for background color or width, they're being declared somewhere else down the page, and it's getting crossed out because of that. So yeah, these are the two projects that we will be working on, or working towards. A personal web page, this is just going to be you can fill it out however you want, but we're going to be making a page that you can set up and put on the internet and then link to, and it can have whatever you want in it, basically. A personal page is very, very basic, and you can use it as a boilerplate for making other websites. And CCTV is kind of a complicated idea, but we'll get there. So join me in the next video where I will begin discussing Python, and we'll be working towards creating a closed circuit television system.